Good day, guys. We'll be talking about EULER second substitution. And in my previous video, I've talked about EULER first sub and how to apply EULER to integration. That's EULER substitution. So we're talking about EULER second sub for today. And it is a process or a case whereby our constant C is greater than 0. Those who can relate to this are those who have read the EULER first sub and they have understand it very well. So let's move on, guys. Let's say you have a particular quadratic equation like we do always have. A normal quadratic equation, which is your ax squared plus bx plus c. Now for EULER second sub, attaching a variable to it, this will give us xt plus or minus root c. And like I had said earlier in my previous video, that this plus or minus sign does not really matter. How you get what I'm saying? So either you use minus or you use plus, you still arrive at your destination. And guys, we need to find the value of x here so that whenever you want to differentiate it, it will be much more easier than you stressing yourself. And take note of this, guys. From this process, we automatically know that our t here would be equals to your root a x squared plus bx plus c. You get what I'm saying? Now you can either say plus or minus root c then over our x. You get what I'm saying? Over our x. So depends on what you are using. If I'm to use plus here, it should not switching it back here would give me what? A negative value. So I actually put this t down simply because you might later need this t in some one or two questions. And moving on to this, guys, from our question mark, let's square both sides. You'll be having your ax squared plus bx plus c equals to your xt plus or minus root c and your xt plus or minus root c. Are you with me? Then moving on, guys, you have your ax squared plus bx plus c. Then this will be equals to c squared x squared plus or minus xt times this, you have plus or minus xt root c, and again plus or minus xt. So you can either say plus or minus cx root c, and you can have plus c. Why is that? Plus times plus plus, minus times minus, you still have plus. Then root c times root c, you have ordinary c. So c cancel out c. And moving on, guys, you have this. We are looking for x, so this can easily come back here, and you will have a minus t squared, then x squared simply equals to your plus or minus, okay, you have, sorry, 2tx. This is 2tx plus or minus 2tx. Why is that? This is the first one, this is the second, this is the first one, this is the second one. So 2tx. So you have plus or minus your 2t root c, then minus, when b comes, it becomes minus b into bracket our x. So x here, divided both by x will cancel out x, then we left ordinary 1x here. Then automatically our x will be equals to plus or minus 2t root c minus b over our a minus t squared. You get what I'm saying? So our a minus t squared. So guys, as you can see, you simply note that our plus or minus does not cross to anywhere. So therefore, if you want to use your positive value, just change this to positive. If you want to use the negative value, just change this to what? To negative. Simple as that. Now we've gotten our x variable. Now I need this t, I need this x variable. How? This is mainly what we need for EULER second substitution. Let's move on, guys. Now let's look at a particular example. Let's say we are to integrate something like this. Integrating the x, then over, you have the function x root negative x squared. As you can see, this means that we can't apply the first sub. Why? You're having a negative x squared. First sub says the process by the a, which is the equation of x squared, greater than 1. Why this is not greater than 1 automatically? Greater than 0 rather. And this is not greater than 0. So you have plus x, then plus root 2. So guys, we are not stressing ourselves. If you are to compare this with what I give you guys here, this process here, this is the x for it. So instead of you stressing yourself, you can easily say our a here will be equals to minus 1, normal quadratic terms. Your b will be equals to 1, and your c will be equals to what? Root 2. So therefore, our x for this variable here would be equals to, our x here would be equals to, I think let's use plus. So we'll be having plus our c is root 2. So we'll be having root 2 as our c. Are you get what I'm saying? So you have sorry, ordinary 2. Let me use that. Sorry, ordinary 2. I'm actually bringing out one of 2 questions for my this brain, so that is why. So let's use 2. So it makes it much easier now. So you have plus 2 our root c, which is root 2. So you have 2 root 2 t. Are you get what I'm saying? Minus our b, which is 1, over our a, which is minus 1, minus t squared. So this can easily be equals to minus into brackets 1 minus 2 root 2 t over minus your t squared minus 1. Minus times minus, okay, plus 1. So this will be equals to 1 minus 2 root 2, then your t over t squared plus 1. So this is our value for our x. 1 minus 2 root 2t over t squared plus 1. So from here, guys, we've gotten our own x for normal example for this question. And after we've gotten our x, we didn't actually need x. We've gotten our this, which is automatically equals to xt plus or minus root c. Are you get what I'm saying? And I've given you guys the value for t already. So moving on to this, we automatically know that our let me bring this one also so that we can quickly break them step by step. This is our x, Abby. Let's come back to here. Our roots minus x squared plus x plus 2 would be equals to xt. I think you are using plus root c, which is going to be root 2, as you all know. So since our x is easily equals to 1 minus 2 root 2t, you'll be having okay, this is minus here, right? Plus you have minus here. Okay, minus 1. Try to cross check in simply because I want to avoid error. So we have this. So you can have your x, which is this, and t times 1 you have t. That's for this minus 2 root 2t squared. Are you get what I'm saying? Over t squared plus 1, then plus your root 2 plus our root 2. So that is the value for this plus our root 2. So let's move on, guys. This is 1 point also for it. So we've gotten our x, our normal value again in terms of t. So moving on, guys, like I said, what else do we need to do? So now we have to differentiate, and differentiating this variable with respect to t, that's our dx, our the x over the t would be equals to, this is a function u and this is v, and using quotient rule, you have v du dx. Differentiating this will give us minus 2 root 2. So minus 2 root 2 times t squared, you'll be having minus 2 root 2 t squared. Minus 2 root 2 times 1, minus 2 root 2. Then we have minus next, that's v du dx minus u, which is dv dx. This will give us 2t. And 2t times 1, you have normal 2t, which will give us minus 2t. Are you get what I'm saying? And moving on again, you have 2t times minus 2. This gives us a plus, because minus is actually before minus times minus, you have plus. And 2 roots, this is 2. 2 times 2, you have 4 root 2t squared. 4 root 2, then your t squared. T times t, you have the t squared. Then over our v squared, which is going to be t squared plus 1 raised to power 2. So this can easily be equals to your 2 root 2 t squared minus 2 root 2 minus 2t, then over our t squared plus 1 raised to power 2. So automatically you should know that our dx here would be equals to your 2 root 2 t squared. Are you with me? Or you can write it like this, or you can easily say, why don't you put it like this? You can have your 2 then everything into brackets, your root 2t squared minus root 2, then what is again, then minus our t over our t squared plus 1, then you have your dt. So you can actually leave that is also still okay. There's nothing bad about that. 2 times root 2, you have 2 root 2t squared minus 2 root 2, then minus 2t. So this is our dx. We've gotten our dx. We've gotten our dx. We've gotten this. We've gotten our x. So let's move on to this variable. Let's insert everything into this variable now. So you're having integrating our dx, which is your 2 into brackets root 2, then t squared minus your root 2, then minus rt over our t squared plus 1, t squared plus 1, that is our dx, as you can see, then times our x. Our x is what? 1 minus 2 root 2t divided by 1 minus 2 root 2t over t squared plus 1, then times our value for this, that's times our root of everything here. Root of everything here will give us t squared minus 2 root 2t squared plus root 2. Actually, I didn't even break this down finish. Let me break this down finish here, so we can have this as a finished goose. So this will give us LCM as t squared plus 1, right? You have the LCM as t squared plus 1, and this will still give us our t minus 2 root 2 t squared. Then this gives us plus root 2 t squared. Are you get what I'm saying? Plus root 2 t squared. And then moving on to this, you have your plus root 2. So you have your root 2. So guys, inserting this into here, you have your t. You have your t minus 2 root 2t squared, then plus 2 root 2. You have minus root 2t squared. Are you with me? You have your minus root 2t squared. That's it here, minus root 2t squared, and plus your root 2, then over our t squared plus 1. So guys, seems like there is something important that we need to do here just to make this looks like this. And what is that thing? Yeah, it is actually what comes to your mind. Exactly what comes to your mind. But let's move on, guys. So having this, you should know this would be equals to so that can it, let me see if this can continue. You have your dt, do not forget. You have so I think let's imagine this to look like this. And how do we make it look like that? You have your 2 into brackets, your root 2 t squared minus root 2 minus t over our is integrating over our t squared plus 1, then over this times this it becomes before I move on with that one, let's move on. 1 minus 2 root 2t. Are you with me? Then brackets, let's even leave it safe to make it, to clarify it better, t squared plus 1 times, now if I'm to bring that minus here, you have minus into brackets, so you have root 2t squared minus root 2, then minus t over t squared plus 1 over t. So as you can see, like I said, you can see it looks more like this now. Then coming back to here, you'll be having your integrating of this. You have your 2 into brackets root 2t squared minus root 2 minus t over your t squared plus 1. And since this is division, you know it is division divided by everything here, and since it's divided by this will change to times by switching up numerator and denominator, and this is actually t squared raised to power, this is raised to power 2, raised to power 2, this is raised to power 2, sorry, this is raised to power 2, raised to power 2, raised to power 2, raised to power 2. Yeah, so raised to power 2 times your t squared plus 1 raised to power 2, then over your 1 minus 2 root 2t, then into brackets, let's just even put it here, times, let's take it like that, minus root 2 t squared minus root 2 minus t, just to make it easier for you guys to understand. So therefore, as you can see, this cancels out this cancels out this, putting our dt, very important. And moving on, guys, you have integrating, this becomes 2 over minus times this, you have minus 1 plus 2 root 2t. So you have integrating minus 1 plus 2 root 2t, then your dt, that's, as you can see, this will become minus 1, then times this, you have minus 1 then plus 2 root 2t squared. So moving on to this, guys, what do we do? Let's think. And from here, guys, I could actually say that let our u be equals to minus 1 plus 2 root 2t. So therefore, our du over the t would be equals to your 2 root 2. Are you get what I'm saying? Your 2 root 2. And from here, our dt would be equals to du over our 2 root 2. So inserting this, you have integrating 2 over our u times du over our 2 root 2. So 2 cancel out 2. This would be equals to 1 over root 2 integrating du over u. And as you all know the answer to this would be equals to 1 over root 2, then learn absolute value of our u, and that will be equals to 1 over root 2, then the ln of our u is actually minus 1 plus 2 root 2t. Are you get what I'm saying? 2 root 2, so you can easily say still the same thing, or you can say 2 root 2t minus 1. There's nothing bad there, plus our constant c, please remember that, plus c. So this is actually our answer. When you get to here, we'll get to mainly the important full aspect. Are you getting what I'm saying? But if you have to break it down fully, this would be equals to 1 over root 2, then our ln of our 2 root 2. Are you with me? And our t, like I said earlier, where do I put it? So this is our t. Now I think that we are going to need it. Why is that? We need more like the x variable to substitute it back into. So this is our t here. So you can just easily insert it into everything. I tell you guys that I used a positive value for that aspect, and as you can see, if I'm to use a positive value, if plus comes here, it becomes a negative value here. So therefore, I'll be having 2 root 2 into brackets. My t becomes root a, and actually self, I don't need to I need to just, I should have used this. This is more like the explanation. This is what we are dealing with. So this is where I should derive my t from. So my t from here, I'll be having minus root 2. So from here, guys, sorry, I was actually trying to couple up into that, though, which is still going to work though, just your minus root 2 then over our x, so that was stressing. So you'll be having minus x squared plus x plus 2 plus x plus 2, and like I said, minus root 2, then everything over x minus our 1, then plus our constant c. So this is our final answer, and I hope you all enjoyed it. So using the EULER face up, which is much more interesting. So this is our final answer, guys. So what do you think about it? You let me know in the comment section, and please follow for more and subscribe, please. Thank you, and like my video. Thank you so much. Oh man.